Hi, I'm Andy, and today I will work through problems 14 through 20 of the science section of ACT practice test number 2. When I first open up a new section of the ACT science test, I'm usually tired of reading from 3 hours of testing, so I just read the first few sentences, or at least enough to have a picture in my head of what the study is about. When two types of bacteria found in the soil of a wetland, land having a high water table, break down organic matter, gases are generated. I also like to look at the graphs so that I know what sort of keywords to look for in the questions. In particular, I look at the titles, so we see the words bog and fen soil, and the axes, where we see WT, total CO2 emissions, and total CH4 emissions. Now I'm ready to jump into the questions. Question 14. The researchers who conducted the study most likely chose to conduct it during the summer rather than during the winter because organic matter in soil is broken down. So we have this picture in our head of little bacteria in soil breaking down matter and emitting gases. So let's look to see if there's more information about why that would be best in the summer. We scan the passage for the word summer, and I always like to highlight keywords from the question that I use to find the appropriate part of the passage with. I see the word summer here at the beginning of the second paragraph, but not any information about why that decision was made. When there's not an explicit answer to the question in the passage, this means that the question is what I call a scientific reasoning question. The best way to approach these questions is to reason through which of the answers makes the most sense. So if we read through these answers, we see they're all about aerobic and anaerobic bacteria, which are, if we noticed up here in the italicized words, are the two types of bacteria that were found in the soil. Now, since this study is studying both bacteria, the decision to conduct the study in the summer must have been beneficial to both. That means the effect would have been the same for both types of bacteria. However, answers F and G talk about different effects on these bacteria by doing the experiment in the summer. And so those answers are probably not correct. Now let's look at answers H and J. The difference here is that H suggests that the experiment was done in the summer because both bacteria break down organic matter more rapidly in the summer, whereas J suggests that they break down organic matter less rapidly in the summer. Now, we saw in the graphs that these CO2 and CH4 are emitted, which we can reason are the gases that are emitted. And if we read closely, those are those gases that are generated. And so the experimenters would want to maximize the amount of gas emitted so that they have the best measurements, the strongest measurements. Since gas emission is the result of breaking down organic matter, we would assume that the experimenters would want to do whatever they can to encourage the bacteria to break down organic matter. So if they chose to do the experiment in the summer, that must be assisting the more rapid breakdown of organic matter, which is consistent with answer H. Now, these can be the trickiest questions in the science test, these scientific reasoning questions, so it's always important to recognize when you're asked to do scientific reasoning on your own and to refer to the passage to get as much information as you can. Question 15. According to the results of the study, as the water table for the bog soil sections and the fen soil sections became progressively lower, did the total CO2 emission increase or decrease, and did the total CH4 emission increase or decrease? These keywords are all keywords that we saw on the graph: fen soil, bog soil, CO2, and CH4. This is a graph reading question. For these questions, it's especially important to be careful about how you're asked to read the graph. In particular, it's asking for you to read what happens when the water table becomes progressively lower. So we haven't seen the word water table yet, so let's scan through. We see water table is abbreviated as WT, so it's the horizontal axis. And we can see that the horizontal axis already gets progressively lower as you go from left to right. So we're reading the trends in CO2 and CH4 to go left to right in these graphs. In both cases, CO2 increases and CH4 decreases, which is consistent with answer A. And even though this was an easier question, it's just as easy to make a silly mistake. And so it's important to double check your answers and run through your reasoning before moving on to the next question. However, we won't do that now. We'll leave that as an exercise for the viewer and look at question 16. One of the reasons the lid on each tank was kept closed for the 3-month period was to, so we see the word lid as a keyword, tank, and then closed for 3 months. So let's look at the passage to see what we can learn about these. We see the word lid here and tank, talking about how the tank had a lid made of glass, but nothing about being closed. We continue reading. We see tank, lids closed for 3 months. And right after it talks about how the gas emissions were measured during those 3 months. It doesn't explicitly answer the question, but we can assume that because you're closing a lid and you're trying to measure gas, you are preventing gas from escaping this tank, which is in line with this idea of measuring the amount of gas that's emitted, because if some gas was exited the tank, it would result in an error in the measurement of the emitted gas. This answer is consistent with answer F. Also good to, if you have time, to double check if the other answers don't make sense, but to save time, we'll move on to question 17. The two types of wetland investigated in this study, bogs and fens, have different levels of nutrients that sustain bacterial growth. Do the results of the study suggest that the levels of the nutrients that sustain aerobic bacteria are higher in bogs or in fens? And do the results of the study suggest that the levels of nutrients that sustain anaerobic bacteria are higher in bogs or in fens? So this is another graph reading question. However, one difference is that it asks for aerobic and anaerobic bacteria, which are words that don't show up on the graph. So we refer back to the definition of these two bacteria, seeing that aerobic bacteria generate CO2 and anaerobic bacteria generate CH4. So for future reference, we note those on the test. And this is a good strategy to make sure you don't make a silly mistake when doing a graph reading question like this. So now we're looking at, now we need to see how these measurements of CO2 and CH4 connect to higher nutrients. Now, because nutrients are what's being broken down and produced to generate gas, as we saw in that first sentence, you can assume that more gas emissions means higher nutrients. So we're essentially answering the question of whether there are more emissions in bog soil or fen soil for the two types of bacteria. And a quick read of the graph shows that in both cases there are higher values in the fen soil, so we select answer D. Again, it's important to double check your reasoning in these graph reading questions. Question 18. Based on the results of the study for the two soil sections that were completely submerged in water, were aerobic bacteria present in those sections? Keywords here I see are soil sections and submerged in water. So let's look for text related to that. So if we scan through, we see soil sections mentioned here, but nothing about water, just their size. Over here, we see soil sections in conjunction with the water table. In particular, it describes how, in the case of plus 1 centimeter water table, the water is 1 centimeter above the surface, whereas in the other cases, the water level is below the surface. That means only in the plus 1 centimeter water table situation is the soil submerged in water, meaning that's the one bar we're going to look at to answer this question. Next, there's another keyword, aerobic, which tells us that we should be looking for measurements of CO2, as we noted in question 17. So if we look at the graphs of CO2 and the water table plus 1 centimeter, we see that CO2 was emitted in both cases, which could have only been done by aerobic, or which we can reason is most likely done by aerobic bacteria. We assume that there were aerobic bacteria present, and our reasoning is because CO2 was emitted from those sections, corresponding to answer F. Question 19. Consider the total CO2 emission from the fen soil section having a water table of -10 centimeters. Based on that result, over the 3 months, The average CO2 emission from that soil section per month would have been closest to which of the following? This is another graph reading question. We're looking at the fen soil section, CO2 emissions, water table -10 centimeters. So that's this bar. The value is a little less than 50, let's say 49. I want the average value, which means we want to divide by 3, since the average is the sum divided by the number of terms, and there are 3 months that are being added to produce this value. 49 divided by 3 is roughly similar to 48 divided by 3, which from your times tables we know is 16. So we choose that as the best answer. Question 20. The study was conducted at an outdoor site near the wetlands to ensure that the tanks would be nearly identical to the wetlands with respect to which of the following? Here we see outdoor site and wetlands and discussion of tanks. So let's scan the passage. We see all tanks were placed at an outdoor site near the wetlands right here. After it talks about water, and before it talks about experimental conditions. So if we, these are what we want to compare to the wetland conditions. So we'll scan through that quickly. We see that there was a small soil section taken out from the wetland. Live plants were removed. These sections were placed in tanks with a lid made of glass. Instrument was put in to measure gas emissions, and then they were placed at an outdoor site. So again, there's no explicit answer, so it's a scientific reasoning question, meaning we want to go through each of the answers and find the most likely. First, amount of precipitation. Now, because we saw that the tanks are enclosed in a lid of glass, any precipitation that hits the outdoor site would not enter into the soil, into the tanks. So F is probably not correct. G, types of plants present. Well, we saw that all live plants were removed from the sections, so these is not a similarity between the tanks and the wetlands. H, volume of soil. Since the tanks had a soil section that was smaller than the size of the wetland that was removed from the wetland, this is also not similar. So we would assume that the answer is J, hours of daylight, which makes sense because the lid was made of glass, so any daylight that hit the outdoor site would also pass through the glass and hit the soil. That's the end of the science section. In the real test, you would only have about 6 minutes to complete this section rather than the 12 or so I just took. But I was explaining each of my answers out loud. You'll go plenty fast if you think about each question methodically and carefully rather than rush through, and you'll get more answers correct too. In particular, use the strategies I covered. At the beginning, just read enough of the passage to get a picture in your head of what's going on. When reading the question, identify keywords. Before answering the questions, scan the passages and graphs quickly for those keywords and determine whether it's a scientific reasoning question, a graph reading question, or just a read the passage question. Last, make sure to double check those graph reading questions to avoid silly mistakes. And when you're doing the scientific reasoning questions, try to narrow down your answer through process of elimination for the most likely answer, even if it's not explicitly stated in the passage, kind of like we did with question 20. I hope you found this video helpful. Good luck to you all on your next ACT.